Hello everyone, welcome back to mathsmood. Here we have interesting exponential equation 16 to the power x minus 12 to the power x equal to 9 to the power x. How can you solve it? The main idea to solve this exponential equation is to divide in both sides by, for example, in our case, let's divide both sides by 9 to the power x. So let's do this. We will have 16 to the power x over 9 to the power x minus 12 to the power x over 9 to the power x equal to 9 to the power x over 9 to the power x. Nothing hard, just dividing both sides by 9 to the power x. What we're going to do next? Of course, if we have different bases but same exponent, we can write it in one parenthesis. So we can write this as 16 over 9 to the power x minus the same thing right here, 12 over 9 to the power x, and the same right here. But right here we will have 1 because we are dividing the same. Okay, what we're going to do next? Of course, we can see that this 4 can be written as 4 square and this 9 can be written as 3 square. And if we divide in this numerator and denominator by 3, we will have 3 right here and we will have 4 right here, so we can figure out with 4 and 3. So let's do this. Let's write this 16 as 4 square. 4 square over 3 square and all raised to the power x minus, and dividing both sides by numerator and denominator by 3. So we will have 4 over 3 raised to the power x equal to 1. Nothing hard, just a little bit simplifying trick right here. Right here we will write our 16 and 9 using square, and right here we divide in both sides by numerator and denominator by 3. So what we're going to do next? Let's use the same logic right here. Let's write this 4 over 3 all raised to the second power. We can use this because we use this rule right here as well. So we will have 4 over 3 raised to the second power, and of course we need to raise to the power x minus 4 over 3 to the power x and equal to 1. And now you need to know about the rule of interchange. We can swap these exponent, these powers. So, what is the rule of interchange? If we have, for example, a to the power x raised to the power b, we can write this as a to the power b all raised to the power x. Just swap this exponent. This is our a, this is our x, this is our b, and we can swap these x and 2. So, what we're going to do next? Of course, we will have an interesting case. If we swap these, we will have 4 over 3 to the power x all square minus 4 over 3 to the power x equal to 1. As you can see right here, we have 4 over 3 to the power x and 4 over 3 to the power x. So let's use a substitution right here. So let this 4 over 3 to the power x equal to, for example, equal to t. So we will have an interesting quadratic equation because right here we will have t squared, right here we will have t, and minus 1 equal to 0. So we will have quadratic equation t squared minus t minus 1 equal to 0. Okay, how can I solve this? First of all, let's find our square root. Our square root b squared minus 4ac will be equal to square root b squared 1 minus, and this minus will be plus 4ac, 4 times 1 times 1 will be 4. So will be equal to square root of 5. And let's write our t first and t second. We'll have two roots. Our t first will be equal 1 plus square root of 5 over 2, and t second will be 1 minus square root of 5 over 2. So we have two roots. But as you can see right here, 4 over 3 to the power x equal to t, this on the left need to be like positive, because we have an exponential function and we need to have a plus right here. So our t need to be positive right here. So t is greater than 0. And as you can see right here, this of course will be positive because we have 1 plus square root of 5, which is positive, and 2 is positive, and as a result we will have plus. So this root is good for us. Take a look right here. Square root of 5 is greater than square root of 4, which is equal to 2. So, of course, in our denominator we will have minus. Over 2 is plus, and as a result we will have minus. So this root is negative, so this root is not good for us. This is good for us, this is not good for us. So we will have only our one root in real numbers. So we will have, as our t equal to 4 over 3 to the power x and our t equal to this thing, we can write an final equation 4 over 3 to the power x equal to 1 plus square root of 5 over 2. This is our final equation, so let's solve this. How can I solve this? Just use a logarithm rule, log property. If we take in log from both of the sides, we will have an x jump right here, and we'll have our x equal to some value right here. So let's take log from both of the sides. Let's take log 4 over 3 on the left, 4 over 3 raised to the power x, and on the right, log 4 over 3 log 1 plus square root of 5 over 2 base of 4 over 3. So as you can see right here, this is the main log property, so we have the same base right here and the same number right here, so this log will be equal to 1, which is good for us. And this x from here jump in the beginning, so we will have only our x on the left. So and right here it will be our answer, so we will have x equal to log 1 plus square root of 5 over 2 base of 4 over 3. We can simplify this a little bit, because we can use the base of 10 right here. So how can I do this? We can write a final answer in a different way, so our x will be equal to log 1 plus square root of 5 over 2 all over log 4 over 3. And of course it's easy to calculate it in our telephone, because we just write our log and log for third and log 1 plus square root of 5 over 2, and we divide numerator and our denominator. So this will be our answer, one and only answer. A little bit complicated answer, because we have logarithm, numerator, denominator, we have square root, but it's really fast to calculate it on our telephone. So this is our answer, this is our solution to this interesting equation. If you agree with this, if you disagree, maybe you have faster method how to solve this, write a suggestion in a comment, write a question in a comment. Thank you so much for watching, put in thumbs up, subscribing, I really appreciate it, and have a great day. Thank you for watching.